Yeah, so let's have a conversation first before we get into the content. So first of all, welcome back. I hope you had a good weekend. I want to talk about some updates to Prismia. So the code cells are quite different now. I'll give you this one to go ahead and start running so that your Python session will be good to go for when we get to it later. But the important point here is that the code cells have been overhauled. So you can now interrupt a running calculation by hitting stop. And also there's some detection for when the kernel dies so that you can hit reset and not have to refresh your browser. It could still happen that you have to refresh your browser, but much less often than before. This button will turn into a reset button when appropriate. In any case, I hope that that's good news. We'll see how it goes. There's another feature that we're going to use a little bit later. For the first line, if you put in hash lang and then either Julia or Python or R, it will coerce the cell into that particular language. So let's go ahead and run this one as well. The Julia sessions take longer to start up, and we will run one line of Julia later. So if you go ahead and run that now, it'll be good to go. So here's another one that I think is kind of fun. You can put, so we have had tables to some extent, but you can now actually, it's usable. Before it was sort of pretty hackish, and now I think it's fine. I think you can put this into your own content. You can export as CSV. You can also group, select particular columns, and so on. I'll show you a particular example of the kind of stuff you can do here. So let's say we're wondering how much height varies by position among the soccer players in the FIFA World Cup. What we can do is press group to group by position. And so that pulls everybody together with the same position. And then we can aggregate with the mean function. And it's going to tell us that. Also, let's kick out some of these other columns in between so we can see. So it's going to tell us that goalkeepers are taller on average. They're 188, whatever the unit is here. I guess centimeters. Does that make sense? Yeah, that seems plausible. Whereas the other heights are more around 180, a little bit of variation, whatever. Point is, the tables are more interesting now and more useful. I would also like to say, kind of changing gears a little bit from that active engagement in class is going to be really important for the learning experience here. So ultimately, if you just want to engage in a casual way, that's fine. But if you're able to participate more and attempt to answer each question that I send, so I'll say I really want an answer here by putting the registered symbol in there. That's going to make class more fun for everybody. So thanks to everyone who's engaging in that way. And I would say maybe even more so that the same idea applies to the asynchronous work. So I've been going through the interactions people have had with the shared lesson so far, and it's been a good learning experience for me in that I can see that people are very happy to click on the suggestion chips, maybe provide like 2 or 3 word responses to some of the other questions. But it seems really hard to sort of convince yourself to write out, full sentences when there's you're not actually engaged with a conversation with a person. So like the idea of the medium is that it simulates a conversation, but it doesn't simulate it convincingly enough because it's not sort of convincing people to write more. But for your own benefit, if you just write out, it doesn't have to be a whole paragraph, just like a complete sentence explaining an idea in response to a prompt, then that's going to be better for you. Lastly, I want to give a small tour of Prismia, because the groups have started to meet and the first assignment is out, and it's going to require you to know a little bit more about kind of how to get around. I don't think it's too complicated, but it helps a lot to have some orientation. So first of all, you can create a new course directly from this pull down here. So top left, and there's a button for creating a new course. And once you've created the course, you can go through, it'll take you to a settings page. You can go through and choose how you want the settings or not, just skip it. The defaults are reasonable. And then when you go back to your chat room, you'll have a classroom card. So I'll show you here. If I pull this one out, I have a classroom button on this DSI summer prep card because I'm an instructor for that course. So when you create a course, obviously that's going to give you access to everything for that course. And so you can click on the classroom button, and from there, the top navigation bar is going to have an option called lessons. That's where I would suggest going first. So that's where you create content that can be used in the classroom or shared, like the shared lessons that you've been looking through for how the Data Gymnasia courses present. And you can use that to prepare shared content. And there's no developer stuff here. It's just a WYSIWYG editor. So it's a rich text editor. You can do like, Command B to bold text and all the kind of stuff you're used to from Microsoft Word or whatever. It's got code cells, figures. The figure support is really nice. You just drag something in from your desktop directly into the message, and then you can center it and change the size and all that stuff just by dragging. You don't have to like learn some new, mini language for specifying how the figure should look. Tables, as we discussed, you can also make quick sketches right in the interface, so you don't have to use some external drawing tool if you just need to do something basic. There's a commenting system and so on. So once you've made a lesson, so you're just going to make a lesson as a sequence of messages. Once you've made a lesson, you can publish it by opening the settings under the gear icon and then clicking share lesson here, and it's going to give you a URL and a little copy button, and then you can distribute it to someone else. So the idea is like, if you want to just write some, have some interesting observation, or you want to explain something, even just for yourself for the future, you can just write it down here instead of stashing it away in some markdown file somewhere on your machine or whatever. And it gives you a way to, quickly pull that content back up. Yeah, the other thing you can do with your shared lesson content, aside from presenting it statically as a website, is share it dynamically as part of class. You might want to use this in your groups. To do that, go back to the classroom link, and it looks something like this. And you have a lessons button here. I don't know how well you can see my cursor, but this beige button on the right edge, that pulls up a lessons drawer, and you can grab all your lessons from there and just click on a message, and it'll populate the message to class box, and you can hit send to send that out. So that's what I'm doing in this class. So for completing assignments, and this is the really the main reason for me to give all this introduction, it's very similar. You go to assignments using the left panel, just pop this out, assignments right there, and maybe I'll just take you into it and we'll look at it together. So this is assignment 1. This is the first exercise. You can click through to see the other exercises by pressing the right arrow button. Whenever you see these figures like this, they're interactive. Here's a question about flags. I think this is a pretty fun problem. And so when you go to solve this exercise, what you want to do is just hit the plus button here, and you just start authoring content. So you can craft your solution however you want. I suggest breaking it up into lots of small messages. So like this is your first message, you click plus, and that gives you another one. You don't need to put everything into one giant message. You also do have a code cell that you can pop up here if you want to interact in that way. You don't have to go separately to a different computation tool. You've got the same thing here that you've got in the classroom. Depending on how complicated the assignment is, you might find it beneficial to work in a different workspace, but it's there if you want it. Okay, let's go back to chat. So I mentioned all of that because, for one thing, you need some orientation for the assignments. The interface looks a little bit different because there's more options there than you have in the chat. And I also just want to say more broadly, my goal is to make this a really easy way to present really rich content that involves math and code, figures, tables, etc. There are obviously a million ways to do that, but I'm actually not too happy with any of them. And my goal is to make something that addresses those points of concern. Like, so for example, we used Fast Pages, which is a great tool last year for folks to make blog posts in Data 1010. But the problem is quite a few folks in the class ended up spending a really long time trying to troubleshoot the pipeline that makes that system work. And the advantage is it's sort of resting on top of GitHub infrastructure, so it's free and it's very highly customizable. But on the other hand, something can hang in some process that's supposed to do something important, and you just have no output. And you have to troubleshoot it as long as it takes, or you've got nothing to submit. And Prismia will, there's some downsides to having it be packaged, but it will certainly save that particular cost. It's just a matter of typing stuff into the lesson and hitting publish. Anyway, all that being said, you should do whatever works for you in your small groups. I realize like learning a new tool is not everyone's jam, especially if you've got a lot of other stuff going on. So whatever you need to do is completely fine. I don't have any interest in putting any pressure on anyone. So before we get started with the actual content, I want to create some space for people to be able to ask questions for anything they might be wondering that's related to the course. Let's go ahead and pick up from last time. So I actually just want to redo this exercise from last time so that we're all kind of on the same page with it. So if you did it last time, then that'll be easy. If not, then you'll have a little bit of work to do now. So 90 seconds left. Write a function that extracts a person's initials from their name. So by the way, you can click on my face here to copy the code. And that way, when you pop open your code cell, you can just paste it in like that. Yeah, so it's interesting. There's some folks taking different approaches here. Let's take a look at a couple of them. Here's one. Yeah, and here's another one. Great. So these are kind of two different approaches. So here we're using the find method of the string. Actually, Nick, do you want to walk us through your solution here?
Yeah, I guess it's the assumption that the initial for its assumption is two names. So you just take the index from the first name, that's name 0, and then you have to find where the letter of the second name is. So that's where the find function comes into play. So it tells the index of the space, and then you take the next letter for the initials.
Yeah, that's great. So this is different from how I set it up, but yeah, this totally works. And then here's another solution. This is more what I had in mind. So you call the split method with space to produce a list of two strings, one of which contains the first name, the other of which contains the second name. Then you loop over that, and for each one, so for each name, you grab the first letter, you uppercase it just in case you need to, and then you call the join method on an empty string to put those back together from a list back into a single string. So yeah, okay, that looks good. And then there's a couple more that have come in. Okay, cool. So yeah, you can see how a few different folks are doing this. By the way, I do recommend writing your solution in the form of a function because that way the testing apparatus will work fine. Otherwise, it won't. So the test underscore whatever, that thing that you see a lot in Data Gymnasium, we've been using it here. That depends on structuring your code through functions. Okay, so one thing that no one mentioned, which is fine because it's sort of out of scope, but it's worth mentioning as well. Initials in the real world are a fuzzy concept. People have different structures to their names. It's not a well-defined sort of rigorous specification to map an arbitrary name of a person on the planet to a pair of characters or any number of characters representing their initials. So it's fuzzy, and it's part of why I just put some very simple examples for the test cases. But this comes up a lot in data processing. You're often, when you're needing to kind of handle data in the wild, there are going to be examples that don't really fit, and you're going to need to think about what you want to do with those. Either take them seriously and try to really get them right, or just let it go and acknowledge that your solution is only going to work for most cases, and maybe in a given setting that's adequate. So yeah, so here we just want to handle the test cases given, and that's it. And so everyone interpreted it that way. That's good. Yeah, so just to rehash what's been discussed, we split the name on the space character and then grab the first letter and uppercase it, and then join them back together. So this works fine. I'll show you. Oh, my Python session has to start up again. That's important. Actually, I should start my Julia session as well. So that's because I navigated to a different page earlier when we were talking about assignments. So just a little side discussion here, not so much about programming, but just about computers in general. So there are more letters other than just A to Z. There are lots of languages on the planet, and many of them use different writing systems. And traditionally that has been a problem because the sort of basic way that strings have been stored for decades only allowed about 100 distinct characters actually. And that's not nearly enough. So What's the sort of, one word answer? What's the modern solution to this problem? Now, this is cool. So people are going to learn something. So one person said ASCII, which is in fact the old system. So that's very close. But the new system that is sort of steadily replacing ASCII is called Unicode. So this is a standard specification, and it contains an enormous number of characters, including all the emojis you use in your phone and lots of other stuff too. It's basically like anything that could plausibly be a text character in any situation, let's include it. And it's set up to scale, so it can handle, having a huge number of characters like that. There's some complexity, additional complexity inherent in that. There's sort of a trade-off there. If you want to be able to represent a ton of characters, you have to make some sacrifices, but they've done a nice job, and there aren't really kind of big competing standards to it. It's like Unicode is where it's at. And in fact, one of the motivations for the migration from Python 2 to 3, so I don't know if you were following that saga, but you're fortunate to live in an era where you're learning data science after that migration, because it was a huge pain in the neck for the entire, from 2010 to 2020. And there were many reasons. I don't want to say Unicode was the main one, but it was a factor. Modern systems really should be handling strings with Unicode to be inclusive and flexible. And you can do that now. So you can just type in characters, really any characters you want, and you can handle those strings in your Python program. I will say, though, it won't let you use characters like this as variable names. So Julia will, but Python is somewhat more restrictive. You can use like Greek characters, but not Chinese ones. So here's another exercise. It's a little bit challenging, so just kind of do your best over the next 3 minutes, and then we'll do it together. So we want to write a function that computes the number of atoms in a molecular formula. So like H2O is going to have 3 atoms. CO2, like 1 carbon, 2 oxygens, it's going to have 3. Butane, this is its chemical formula, CH3, CH2, CH2, CH3. So that's going to be 14, because you have like 1 carbon, 3 hydrogens, 1 carbon, 2 hydrogens, and so on. You get the idea. So, and occasionally you'll have a lowercase letter, and you want to ignore that because that's part of the name. So this NaHCO3, the Na is just 1 atom. So just see what folks can do with that. We want to just, again, write a function that takes in a string like this and then returns the correct number of atoms for that string. And no parentheses. If you know about molecular formulas, they can't have parentheses. That's too much complexity. Just handle these basic types for now. So I'm realizing I'm not getting as much live feedback as I thought I would. And I'm realizing that might be because the most natural thing to do is pop this open and work in this workspace. So maybe I should put the telesense, or whatever you want to call it, on this too. Right now, it's just on this text field and this one. But in any case, this does appear to have been quite difficult, which is fine. We'll walk through it together. Well, okay, so some folks are definitely making some progress here, but it's mostly pretty limited, it seems. I haven't gotten any submissions yet. So let's maybe back off of that a little bit and just talk about algorithmically. So forget code. What's the idea for how you should do this algorithmically? Yeah, that's a great answer. A couple of really good answers here. So we want to count each capital letter as a 1, and then if we do see a digit that follows, then we count it more than just that once, and then we'll get a contribution for each capital letter, and we'll sum the results. Yeah, and this is the same idea, but at a higher level. Separate the formula into its component parts and total them up. Yeah, so what we want to do is look through the characters, and for each one, we count it once if there's no digit after it, and we count it however many times the digit after it specifies, if there is one. So we can write the code that way, where we get to a certain character and then we look ahead one and decide how to count it. That's completely fine. It is a little more complicated though, because like when you get to the end of the string, you're going to have an error if you try to look one character forward, because that will be off the end of the string. So you have to write some logic to account for that. It's not the worst thing for sure, but there's a little bit slicker way to do it, which is to just count every uppercase character as 1, and then also count every digit as that digit's value minus 1. So like when we see H2O, we'll count the 2 as 1 rather than 2. Just quickly, why the -1 there? So we already counted the atom once when we counted the uppercase letter, so we don't want to double count it. Okay, so here it is all together. This is what I have. So we're defining a function num atoms. We'll put our doc string here. And there are various ways to go about it. This is one simple one. Just start with a variable set to 0 and then add to it as you go. So for each character in the formula, if it's an ASCII uppercase character, then add 1 to the total so far. If it's a digit, then convert the character to an integer. So it's going to be a string which stores a single character. You have to convert that to an integer, and then subtract 1, and then increment total by that amount. And then once all that's done, there's a typo here. This should say total at the end. And also it looks like this didn't indent enough. Okay, so that I need to fix that. But anyway, this is the idea. This works. There were a couple of submissions. Yeah, great. This came from earlier, and actually it implements the very same idea. So this is it. Takes as an indication it's a solid idea. Yeah, here's someone who knows the Python string methods better than I do. So is numeric is probably a smarter way, and is upper is probably a smarter way than checking whether they're in these particular lists that I exported from the string module. Okay, cool. Yeah, so thanks for that contribution. One other question I want to address. So someone in the last cluster block asked, how do you submit code? So you type your code here in this box, and then when you're happy with it, you can just copy it. And then if you want to put it in a code environment, you do 3 backticks and then a space to get a code environment, and then you can just paste it here and then submit it. You do have to submit through this message button. It would be nice if there was something that sort of kicked down whatever the contents are here into this message box, but you have to do that but it's not that difficult. You just copy 3 backticks and a space and then paste, and you can hit send. So Nick, did you Google the string methods just now? So Nick is saying that he Googled these. Right. So it's a question from Hardy. So in the solution, you're checking for membership in the corresponding lists, and they don't overlap. Yeah, that's true. But if they did overlap, it would this condition would. Oh no, I see. There would be a problem. Yeah. So if there were things that were both ASCII uppercase and digits, both of these if blocks would run, and that would be a problem. But yeah, they don't overlap, so it's fine. That's a good point. I should maybe do an else if just to be a little bit safer there. But okay, so moving on, let's talk about numeric types a little bit. So again, instead of giving a from scratch introduction, I want to try to talk about something a little bit interesting to provide some extra context. So the core content is going to be in Data Gymnasia. But in any case, so in Python, there are 2 different numeric types. This is very common. It's not universal. There are languages that just have 1 numeric type. Python has 2. There's the int and the float. And these are completely different schemes for representing numbers using what's called a bit string, just like a string of 1s and 0s, because that's ultimately how the computer has to store your numeric type. And of course, there are numbers which are integers that they can also be represented as floats. And but the thing is, they represent it in a totally different way. So Python does not let you do this, but Julia lets you take a look at the underlying bit. So if you have a number like -3.0, so that's a float in Julia and in Python. Yeah, so the string of bits that represents -3.0 looks like this. And that's true in Python as well as Julia. The string of bits that represents -3 looks like this. So it's just a completely different representation under the hood. There's not anything similar about the 1s and 0s that represent these things. So that's why, as we were saying, it's really important for the computer to keep track. Is this a float or an int? Under the hood, they're very different. Yeah, so I'm just going to put this there. We did run that code, and we can see the output. But okay, so Python Python's float behaves in the same way as other languages' floating point types. This is essentially universal in computing. There are languages like Pirate is one of them that does this a little bit differently, but it's very rare. Almost every language you deal with is going to do floating point numbers the same way, and we'll get into why in Data 1010. It's an interesting story, but they're imperfect. Like 0.1 plus 0.2, everyone knows from grade school that that's 0.3, but the computer disagrees. It thinks that it's this slightly different number, even though it does. I can ask it to print 0.3 and it will do that. It's not like 0.3 is an impossible value for Python to print for you. But then also you can go out of range. So if you try to raise 2 to the 10,000, then you're going to have a problem. This goes beyond the range of values that can be represented by floating points, and that can always be an issue. Depending on what you're doing, if there's some intermediate calculation that involves dealing with really huge numbers before you come back down to earth, to like regular person numbers, things can break where they wouldn't in pure math, they will in the computer. And the reason for this is that the computer can't in general represent real arithmetic. There are people who would say that real numbers are not even a thing. It's just a figment of our imagination. You can't compute with them. You have to compute with some imperfect reflection of them. And this is just one particular choice, but it's the one that kind of, rules the world. Every system is going to give this unless it's specifically hard coded to avoid it. Conversely, though, Python does try to be a little smart when it comes to ints. Integers are the sort of thing you can represent perfectly. When you do integer arithmetic, it can be completely perfect. And Python really tries to do that. So obviously, at some point, you're going to run out of memory on your machine. But like 2 to the 10,000 is no big deal for Python. You can even crank it up. I'll take the underscore out. So that's just the underscore is just a digit separator just to make it easier to read. It's like 2 to the 1 million. It's fine. So, it's a lot of digits, but Python was okay with that. All right, so the point is this is not an ordinary int if you're used to ordinary integers from other languages. It's smarter than that. But the problem with having an integer type that's too smart is that it's also too slow. So if you're going to do serious numerical work that involves like a lot of number crunching, you really don't want to be using Python ints because they are Python objects. They're not sort of like lightweight, really fast, easy objects for your computer to manipulate. So what you're going to be doing most of the time in Python is pulling in from NumPy an array type and dealing with arrays. So here's an array with just one entry. Here I'll make it have 2 entries for you. But in either case, you see that if you raise 2 to the 100, so this is exponentiation operator in Python, or 4 to the 100, either way, you're going to get 0 out as a result. And we'll talk about why that's the case in Data 1010. Basically, this is just the way that integer arithmetic responds to this particular kind of overflow. If you do 3 to the 100, you get some other junk and it's negative. So this doesn't make sense either until you understand like what actual operation is being performed here. But all that to say, Python doesn't really escape the hazards of integer arithmetic because you end up having to use NumPy for most things, and you're going to have the same problems you're going to have in other languages. All right, so I mentioned most of that just because I think it's interesting. I think it's useful to have kind of a preview of that. And it's a little bit of, you need to deal with numeric types. So just a little bit of introduction to that is useful. So here's another section we're stepping into, which is string utility. So we've seen some things you can do with a string, like split a string on a particular character into a list of substrings, join an array of strings to go back to having a single string. You can uppercase the characters with the upper method. And I would say that, in general, manipulating strings is an extremely common programming task. That's true for general programming. It's also true for programming in data science because you're handling string data coming from the real world. You're needing to do all kinds of stuff with it. And it's really handy to have some facility with that, be able to grab the simplest, fastest thing rather than kind of re-implementing everything as you need it. You can learn all about the different core string types by looking. So str in Python is the string class. And then if we look at dot double underscore dict double underscore, as we mentioned previously, that's going to contain a lot of information about the things you can do with that type. So this is kind of a general way of accessing more information about a type and seeing kind of what's going on with it. What can you do? What are the methods available? So we've seen some of these. I guess I'm going to see some of the ones I overlooked earlier. So yeah, so is upper, is numeric. So that's what we really should have been using earlier. And then there are some of them that are like, wait, what is that? Like zfill or you know, strip. Maybe it's not super obvious what strip is going to do, but you can kind of play around with these and see what each one does. And it's helpful to know in advance what's available, because then when you're solving a problem, your brain, your like subconscious mind can sort of grab that out of its memory instead of you having to hunt for it when you need it all the time. So yeah, so let's say we saw something like rjust in this list, and we were like, what is that? So you can do question mark from the prompt and get some help on that method. And it says it turns a right justified string of specified length. So we call rjust on a string, and then we supply the width argument, and it's going to sort of pad it out. It's going to make it, it's going to supply some initial space characters at the beginning to make it have the right length. Yes, this is default fill character as a space. So let's just do a small kind of simple exercise. So print a list of random numbers between, let's say 1 and 100,000, which are aligned on the right like this. So if you just print them directly, they would be aligned to the left. And we're going to say here, we want them to the right. And I'll spot you some helpful information, which is that you can do import random, from random import rand int, and then you can generate random integers. Like from 0 to 9, you would do 0, 10. Yeah, this ability to see what people are doing is extremely helpful, because I've only got one submission, but a bunch of people are working on it and making good progress, and I can see what's going on with that. So here's a good solution. Yash, do you want to walk us through your solution that you submitted? Yeah, that's great. Yeah, that's perfect. Yeah, but nothing really to add. That was exactly the same solution that I had. Right. So I'll just, put mine out there too, so that it's there, but it's really the same thing. Yeah. So a couple of comments, and just based on what I saw when people are programming. Typically, if you're using the dot append method a lot, you can replace that with list comprehension, and it's nicer. So I noticed several folks using the dot append method, and that's fine. So this is where you make a build up a list by starting with an empty list and then calling the dot append method on that list to add stuff to it inside of a for loop. There's sometimes when that's good. Typically though, when you're using that design pattern and it's something pretty small, you can use a list comprehension. It's a little bit more concise. The other thing is that you want to be calling string methods on string objects for the most part. So like hey dot upper instead of str dot upper of hey. Man, it's hard to type that fast enough. They're equivalent, but this is preferred. It's more concise. It's clear what's going on. This is more typing, and the role of the class here is not really, it doesn't warrant being inserted here. I mean, really, you can do whatever you want ultimately, but it's not idiomatic Python. This is the idiomatic Python way to do it. The reason we look it up from the string class is because, just from the help function, is because we don't want to have to make up an arbitrary string just to access particular methods. You can just work directly with the class. But then when it comes time to call it, you want to call it on an actual string. I'm just going to mention some other kind of handy string methods. So one is strip. So strip will eliminate leading and trailing white space. This is a really common task, actually. It happens all the time. You're processing some data, and then just the way it's processed, you end up with some spaces at the beginning of or end, and you just want to get rid of them to kind of standardize the text. The strip method will do that. Another one which we've already seen is the find method. So that's just going to look for the first occurrence of a particular substring within the string. So for example, if we run the dot find method in these three instances, it's going to say LO space W. That's where it found that substring right here. It found H at the very beginning, and it found Z. Well, let me ask you. So why does the last line return -1? Yeah, exactly. So what's going on here? You can sort of guess just from the output, but there's no Z in there. And so this is apparently this method's way of saying there's no Z. And the idea is like, well, you're returning integers for all these other instances where you do find something. So it'd be kind of nice to return an integer rather than some other type. And -1 is never a possible answer for where you found it because the indexing starts at 0. So you can say -1 as just sort of, it's called a sentinel value. So it's nominally a numeric value or a value of the appropriate return type, but in fact, it's just signaling that some other condition holds, like the string wasn't found. So that will typically have to be processed separately, or you'll have to process the output of this function in a way that accounts for that exception. Okay, this is an astute observation. So -1 is, in Python, it does give you the last index. So like, hey, bracket -1 will return Y. So yeah, this is absolutely true. You need to be careful here. So if you, for example, if you interpreted the output of this find method as telling you an index that you could go grab to get that character, then you would make a mistake here because you get -1 out and then you would index this string with -1 and it wouldn't say there's an error, this doesn't make sense. It would just give you the D at the end and you would expect it to give you a Z. And the reason is that, if you actually ask for the last method here, sorry, the last character, it will return the index counting from 0. But it does illustrate that there's some hazard in these sentinel values, especially if they have some actual meaning in the context. You have to handle them separately or you'll make mistakes. Okay, so just mention one more thing. I don't really have much to say here, just kind of draw your attention to it. Python didn't used to have this, and I think it was a really kind of a problem. If you're used to this from other languages, it really feels like a big omission in Python, but now they have it and it's great. So F strings are a really clean way to bring values from the language into a string. So you're outputting a string for some purpose and you need to grab a value from your Python session to kind of stick into the string. You put an F immediately before the quote mark that opens the string, and that allows you to use curly braces inside the string and interpolate values from the Python programs. For example, if user is this dictionary and we want to grab the user's balance, we can just put that indexing operation inside of curly braces in an F string, and it works beautifully. So there are other more traditional ways to do this. To me, they feel very clunky. This is really readable and solid, in my opinion. I would encourage you to favor using F strings for string interpolation. Okay, cool. That's an excellent stopping point. Next time we're going to go into another exercise that I have ready here, but we'll have plenty of time to unpack that then.